we're going to look at some ideas with radicals that may not follow my jail analogy, or it's just another way of thinking of it. What I mentioned to you, square root of 9, we know that's 3, and the reason is because 3 squared gives you 9. So that means you square this and it gives you what's under the radical. Similarly, cube root of 8 is 2, and that's true because 2 cubed equals 8. We're taking the 2 and cubing it to get what's under the radical. Another way of saying this is if I said cube root of 8 and we don't know the number, let's call it box, it's equivalent to saying box times box times box 3 times gives you 8. And then we think of what number can you multiply 3 times to give you 8. And we know that number is 2. But let's look at, suppose I say the cube root of negative 8. That's some number, we'll call it box. We don't know what it is. The equivalent tells us that box times box times box, when you multiply that number, which we don't know, 3 times, we have to come up with negative 8. Well, sure enough, multiplying a negative 3 times gives us a negative. So we can put negative 2 in here 3 times. So negative times a negative times a negative gives us the negative 8. So negative 2 is the cube root of the negative number. But let's look at square root of negative 4. And we'll say we don't know what it is, let's call it box. Because it's square root, it means the equivalent is box times box has to equal negative 4. It has to be the same number in both boxes because that's the answer. So we think what times what equals a negative. Well, if the number's positive, positive times positive would not equal a negative, and negative times negative is not negative. So for this problem, there's no real answer. So there's no real number. And later on, we're going to find out that that number is called an imaginary. Later on, we'll get to know that that's called the imaginary number 2i, but we won't deal with that right now. What we'll notice is with the square root, you had to multiply two of the same number twice, or 2 times 1 box times a box to get a negative. So similarly, if I say the 4th root of negative 16, it's a similar situation as the square root. In this case, multiplying a number 4 times is supposed to give you a negative 16. But similarly, no positive number multiplied 4 times becomes negative, and no negative number 4 times becomes negative. So for this one, this would be no real number. But it is not an imaginary. Only square roots are later called imaginary numbers. We're going to now look at another example. If I said simplify square root of x squared. If I think of this, this is square root of x times x. In this problem, if I say assume x is any real number, looking at this, we'd say, oh, there's a pair of x's, so out comes an x. And just looking at that idea of jail, we would think x would be the answer. Since x could have been any real number, even a negative one, our square root answer has to be positive, so I have to put absolute value around that answer. Only if I tell you x is any real number will you need the absolute value. However, if I had said assume x is any positive number, if I said assume x is any positive real number, then square root of x squared, which would have had the x times x. Again, that pair would have broken out. You would have an x, but because x is positive, you would not need the absolute value. So it's all in how it's described to you. If they tell you x is positive, you don't have to worry about the absolute value. If we go back, we'll see this only is necessary when you're dealing with an even index of a radical. When we dealt with cube root, if with the number inside is positive, the cube root is positive. If the number inside is negative, the cube root is negative. We don't have to worry about that. So now there's some terminology that we have to keep in mind when we talk about radicals. Any radical, if I say the nth root and I put box underneath, the n is called the index of the radical. The inside of this radical expression is called a radicand. It's the inside. The index is important because it tells us like how many, the group that you have to break out of jail. So that's an important part. We'll go to the next page and just see some other things that come up with radicals that can present difficulty. We'll look at the difference. Let's say A is the square root of 9 versus B, which is minus the square root of 9, versus C, which is the square root of -9. We're going to look at those three because they're very different. So for here, square root of 9, we know this is 3. Minus the square root of 9 is like saying minus 1 times the square root of 9, which is like minus 1 times 3. So that answer is -3. And this, we know, is not real. And we'll see later on that this is called 3i. We're going to do another 3. In this case, we'll suppose that x is any real number. So A will be square root of 25x squared versus B is minus the square root of 25x squared versus C is square root of -25x squared. This first one, we know the factors of 25 are 5 times 5. We've got the two x's. Normally, out would come the 5. Out comes the x. But because x is any real number, we have to make sure the answer is positive. So we put the absolute value. This one is like saying -1 times radical 25x squared, which we just did. So it's like multiplying -1 times what we have here. So it's -5 absolute value of x. And now under here, x squared would always be positive, and -25 is negative. The inside is negative, so this would be no real answer, no real number. Later on, we'll have an expression in terms of the complex numbers. So in this case, let's suppose x is any real number. And I ask you to simplify the fourth root of x plus 2 to the fourth power. So this is the fourth root. I have x plus 2 being multiplied 4 times. And this is the fourth radical, so it takes a group of 4 of them to break out of jail. So out comes 1x plus 2. However, x is any real number, so we want to make sure our answer is always positive. So you must have the absolute value.